in this class, we'll quickly learn about how do you convert your decimal system into byte or this binary system. How do you convert binary back into decimal? And this kind of fundamentals. So let me take again. And this is easy. We pay attention and you will learn it in one shot. So 8, right? 1, let's start with 0. 0, 1, 2, 3, 4, 5, 6, 7. So there are total 8 blocks I created. Each block will have either lights on or off. If it is on, I'm going to put it in green. And if it is off, I'm going to put it in blue. So this is off, this is off, this is off. And this one is on, and on, right? You can see there is an on, off, off, on, off, and again on. Yeah. Now, how do you know if I give you a set of, set of data like this, if I give like a combination of on and off, how do you know what the value, in terms of decimal? That is what we are going to quickly learn. It's pretty simple. What we are going to do, similar to a decimal system, we are, right? This is nothing but you will take the value, either 0 or 1, right? The off, if it is green, it's on. If it is off, 0. So what we are saying is this is 1, and when it is off, the value is 0. So I'll put in different way rather than putting green. So we are saying on, so 1, off is 0, 1, 0, 0, 1, 0, 1, right? 0 is off, 1 is on. And what is the value in this one? Like you can notice, you will see here, is a similar pattern. We are gonna do the number itself, which is 1, multiplied by, rather than taking 10 to the power 2, 10 to the power 3, base 10, the base is gonna be 2 here because you have only on and off. So it will be base to the power 2. 0 is house number here. For this value, it will be 0 multiplied by 2 to the power. House number is, or think of position number is 1. So it will be 1. This is position number 2. So for this one, it will be 1 multiplied by 2 to the power 2. So this one, it will be 0 multiplied by 2 to the power 3. Like this. So if you look at this number, it will be 1 multiplied by 2 to the power 7 plus 0 multiplied by 2 to the power 6 plus, 1 multiplied by 2 to the power 5 plus 0 multiplied by 2 to the power 4 plus 0 multiplied by 2 to the power 3 plus, so I got 1 0 1 1 0 1 0 0 0 0. So 1 0 1 I need to do 1 multiplied to the power 2 plus 1 multiplied by 2 to the power 1 plus 1 multiplied by 2 to the power 0. And the reason it looks a little complicated, but actually it is not. Yeah, go ahead, Dev.
So, do you want us to always make this graph if we are translating binary or decimals into binary?
Yes. So it is for you in the beginning when you learn it. It's much easier when you do this. You will write like 1 0 1 0 0 0. If I give you a number, what you're going to take is take the number multiplied by 2 to the power of position number, and then you simply equate it or compute it. But eventually you will learn it and you will become faster, and you don't have to do it. And this is just for your knowledge, especially when you're in the 9th grade. If you take AP Computer Science Principle, this is one of the chapters they'll teach you. It's just a foundation that you should understand rather than focusing only on syntax, to understand a little bit of basics of how computer really works. Make sense? So let's see, I'm going to put 1 1 1 0 0 1 0 1. This is a binary number, right? 8 bits in 1 byte. And this is 1 byte actually altogether. The number itself is 1, and it has a position. What is the position? 0. So when you say 0th position, the position value is 1. When it's a position, because this is 2 to the power 0, right? Because 0th position, this will be 2. Why? Because it will be 2 to the power 1, isn't it? If you look carefully, it is the position number that matters. The value is 1, but it will be 2 to the power 0 1 2. So 2 to the power 2, which is nothing but 4. So this will be, if you look at the pattern, it will be 1 2 4, 8, 16, 32, 64, and 128. Why 128? Because again, this is the seventh house. 0, 1, 2, 3, 4, 5, 6. Out of 8, if you start with 0, the last will be 7. So it is 2 to the power 7, which is nothing but 128. Make sense? Yes, Shan?
How did you get on 111001? So how did you get it?
This is just a binary number. I'm just throwing a random binary number.
Okay.
Okay. And now I want you to convert this into decimal. How do we convert into decimal? Each number you take, and also you take the position value of that number. So position value is 1. For this is position value is 2, and this is fixed. You can simply write it 1, 2, 4, 8, 6, 16, 32, 64, and 128. You can simply write it. And then you go by and multiplying this with this, it becomes 1 here. So similarly, you take this 0 multiplied by 2, this becomes 0. You take 1 and 4, multiply 4, 0 and 8 is 0, 0 and 16 is 0, 1 and 32 is 32, 164 is 64, and 128 is 128. And now you can add all these numbers. Got it?
Yeah.
Mika? Yes. Okay. Varun?
Yeah.
Okay. Cool. Okay. I'm glad you guys wrote it and I was not even paying attention. Okay. So this is how you convert a binary into an equivalent decimal number.